What is a voltage monitoring relay or VMR? A voltage monitoring relay is a protection device whose function is to monitor power supply voltage and provide a safe shutdown of equipment in the event of voltage abnormalities. How does voltage monitoring relay works? Three-phase VMR have a built-in microcontrol unit or MCU, which monitor power supply qualities like undervoltage, overvoltage, phase imbalances or asymmetry, phase sequence, and phase loss. Once any of these is detected above or below the trip value setting in the VMR, the relay will send an output signal to isolate an electrical equipment from the power supply. Here are the sample applications of a voltage monitoring relay. It can be used as a protection device in the distribution panel. If integrated to a main breaker control, it can isolate a number of feeders to protect different loads from voltage abnormalities present in the main power line. It can also be used as an additional protection device for motors. VMR output contact can be wired in series with the thermal overload device, wherein a voltage quality is required to operate the electrical equipment properly and safely. To understand more of the VMR, let's get familiar with basic VMR specifications. Supply voltage. This is the rated voltage of VMR that match with system voltage that need to be monitored. Frequency, 50 or 60 Hz, depending on the standard frequency your country is using. Depending on your system requirement, there are 5 basic protection functions that you can include in your specification list. 1. Overvoltage. 2. Undervoltage. 3. Phase asymmetry or phase imbalance. 4. Phase loss. 5. Phase sequence or phase reversal. Time delay. Your VMR will have 2 time delay functions. First, on delay, when the relay receives normal power, the output signal changes status after the on delay timer elapse. Trip time delay. Once the relay detected a voltage abnormalities, the trip timer starts to count, and output contacts change status after the trip time elapses. Output contact. Specify the number of normally open and normally close contacts. Rated ampere. Contacts are specified to indicate the current load limit. LED indication for active fault signals. This makes troubleshooting easy, as the voltage abnormality is visually available in the relay. Here are the sample settings for voltage monitoring relay. Please follow the design settings or manufacturer recommendation for your applications. For undervoltage protection, 90% of system voltage should be the undervoltage tripping value. If system voltage is 230 volts, then the calculated trip value is 94% of VMR setting. Turn the UV % knob clockwise until 94%. For overvoltage setting, the trip value should be 110% of 230, which is equivalent to 253 volts. After calculation, in reference with VMR setting, this is equivalent to 115%. Turn the OV % dial knob to clockwise position until the 115% mark. For phase imbalance, the sample VMR is factory set at 10% of 220 volts. Phase loss is factory set. Any one of the phase lost, the relay will trip in 100 milliseconds. Phase reversal is also factory set, and trip time is 100 milliseconds. VMR protection functions. Undervoltage function. The relay measures in real time the average voltage of all 3 lines and compares this to the voltage set point. Undervoltage conditions occur when the voltages in all 3 phases decreases simultaneously. Let's say from 230 volts, the system voltage goes down to 205 volts, which is below the UV trip setting. Once undervoltage is detected, the timer trip starts counting, and continue to count if the voltage remained under the trip setting. In 5 seconds the undervoltage activates, UV indication on and the output contacts change status. Similarly, overvoltage occurs when the voltages in all 3 increase simultaneously. Once overvoltage is detected, in 5 seconds the overvoltage trip activates, and output contact switches status, from NC to open, and NO to close. Overvoltage LED will be continuously on. To protect the motor winding from heating due to phase imbalance, the relay monitors each of the phases. The imbalance is detected when the voltage in any one phase falls by 10% of VMR supply voltage. If detected continuously in 5 seconds, the relay trips and the output contacts changes status. The asymmetry and reverse red LED will be blinking. If complete loss of a phase, or single phasing of power supply is detected, the relay will trip and disconnect power to the motor within 100 milliseconds. All LED indications in off condition, and output contact switches status. If a motor experiences phase loss, it will draw high current from the remaining phases, because the load will be carried by the remaining energized windings. And this causes the excessive heat on the motor windings. Insulation will fail, windings burn and will damage the motor if not isolated from power supply. The VMR monitors the sequence of the 3 phases. Changing the sequence of any 2 of the 3 voltage phases, known as phase reversal, can be extremely dangerous, as it will cause a change in direction of rotation for motor. When phase reversal is detected, it disconnects the motor from power within 100 milliseconds, by changing relay output contact status, and then reverse phase LED indication turns on. Let us study the function and operation of VMR in a motor starter. With the schematic and pictorial diagram, let us see how the VMR functions and operate to protect the motor from any voltage abnormalities. We have DOL starter in a 230 volts 3-phase system. The starter circuit shown is very basic and used in a small equipment setup. Let's say a 3-phase voltage is available from the upstream. The VMR measures 3-phase voltages from its terminal L1, L2 and L3. When VMR detects normal voltage level, the on-delay timer starts to count, and after the on-delay setting of 3 seconds, the output contacts switch their status. Now switch on the power and control circuit breakers. At this condition the motor is ready to start. Turn the on-off selector knob to on position. The control voltage passing VMR terminal 25 and 28 output contact, and thermal overload relay 95 and 96 NC contacts, completes the loop to energize the contactor coil. KM1 main contacts close, then 3-phase voltage goes into the motor, and makes it start. The motor will continue to operate if the current and voltages are within the normal operating range. If the main power supply experiences an undervoltage, below the UV set in the VMR, the timer starts to count. After the trip time of 5 seconds, the UV LED turns on, and VMR output contact 25 and 28 will open, interrupting voltage to the contactor coil. KM1 main contacts open, then disconnect 3-phase voltage to stop the motor. At this point, VMR continuously measures the 3-phase voltage from its input terminals. When the voltage returns to its normal level, the on-delay starts to count. When it reaches the time setting, VMR automatically resets. The output contact terminal 25 and 28 switch back again from close position. The control voltage for the contactor coils will be available, energizing the contactor, closing its main contacts, then supplying voltage into the motor and making it start. If you are interested to see more of this presentation, please support my channel, like, share, subscribe, and click the notification bell so that you will be updated for my next video. Thank you for watching.